ரெக்கார்ட் பண்றதுக்கு ரெக்கார்ட் கொடுத்துட்டேன்.
ஹலோ ஹலோ மேம், கேக்குதுங்களா வாய்ஸ்?
சரிக்கா.
ஹலோ ஹலோ மேம், ஹலோ மேம், ஹலோ கிளாஸ் மேம், கேக்குதுங்களா? ஹலோ வாய்ஸ் கேக்குதுங்களா? ஹலோ மேம்,
ஹலோ 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 யார் இருக்கான்னு தெரியலையே. அங்க சாரோடதுல திலகா தான் இப்போ இருந்தாங்க. ஹலோ ஹலோ
ஹலோ ஹலோ மேம், அன்னைக்கு செக் பண்ணிட்டோம்.
உங்க பேசுறது இல்ல, கிளியரா கேக்குது.
ஹலோ யார் வரணும்? ஜாயின் பண்றேன். கணேஷ் சார், ஹலோ மைக் செக். கணேஷ் சார், கணேஷ் சார், ஹலோ ஹலோ செக் மைக் செக். ஹலோ ஹலோ சார், ஹலோ 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 சார், ஹலோ ஈச்சங்கோட்டை. ஈச்சங்கோட்டை வந்துச்சு.
சார் குட் மார்னிங் சார்.
குட் மார்னிங். கேமரா ஆன் பண்ணுங்க.
எஸ் சார். ஓகே சார். ஆடியோ வீடியோ எவ்ரிதிங் ஓகே.
ஆடியோ ஓகே, வீடியோ இன்னும் வரலீங்களே. நாங்க ஷேர் பண்ற ஸ்லைடு தெரியுதா? நாங்க ஷேர் பண்ற
எஸ் சார். எஸ் சார். விசிபிள் சார்.
ஆமா
சார்
என்ன ரெஸ்பாண்ட் பண்றது?
ஹலோ
ஏய் இருங்க இருங்க. நீங்க பேசிட்டு இருக்கீங்க. இதுல கேக்கலையே.
கேட்கலீங்களா? ஹலோ மைத்திலி மேடம், மைத்திலி மேடம். கூட பேசுங்க.
அபிகா வாய்ஸ் கேக்கல. எதுவுமே கேக்கல. ஒரு நிமிஷம் இருங்க. இப்ப பேசுங்க.
ஹலோ
இப்ப கேக்குது. ஓகே. நீங்க நல்லா தெரியுறீங்க. ஆனா என்ன பார்க்க மாட்டேங்கிறீங்க. ஓகே ஓகே.
ஃபோன் கட்.
ஹலோ மைதிலி கேக்குதா?
கேக்குது.
சரி, எந்த பக்கம் பார்க்கணும் உங்களை பார்க்கணும்னா?
உங்க லெஃப்ட்.
லெஃப்ட் இப்படியா?
இல்ல இன்னும் கொஞ்சம் இப்படி இப்ப நீங்க இருக்கீங்க பாருங்க. கரெக்ட். பெர்ஃபெக்ட்.
ஓகேயா?
ஓகே.
சரி ஓகே, அப்ப கேமராவை தான் நகர்த்தணும்னு நினைக்கிறேன். ஆனா அவங்க இப்படிதான் பேசுவாங்க மைதிலி.
அப்ப நீங்க அந்த சைடு போய்க்கோங்க.
அப்ப
அப்படி
கேமரா
போனீங்கன்னா உங்க பேக் மட்டும் தான் கவர் ஆகுது.
என்னது?
இன்னும் லெஃப்ட் போயிட்டு ரைட்ல டர்ன் பண்ணிக்கோங்க. உங்க
சரி.
அப்படி அப்படி டர்ன்.
ஓகேயா?
இந்த இது ஓகே.
சரி ஓகே. சரி, அவங்க கிட்ட சொல்லிரலாம் நாங்க. சரி ஓகே மைதிலி, அவங்க வரட்டும், சார் வரட்டும், டெஸ்ட் பண்ணிக்கலாம்.
ஓகே டன்.
ஓகே.
சார் செல்லமுத்து சார், குட் மார்னிங் சார். செல்லமுத்து சார், குட் மார்னிங் சார். வரல நினைக்கிறேன்.
ஃபேஸ் பண்றீங்க கிளியரா இருக்கும்.
ஹலோ டெஸ்டிங். ஹலோ ஹலோ.
Hello, hello, mic testing. Hello, hello.
அதே மாதிரி தான். விசிபிளா இருக்கான்னு மட்டும் சொல்லுங்க.
Hello, hello, hello.
ஹலோ அண்ணா கேக்குதா? ராஜேஷ் அண்ணா. ஹலோ
Hello, hello.
அண்ணா
நான்
கேக்குதா?
கிருஷ்ணகுமார் பேசுறேங்க. கேவிகேல இருந்து பேசுறேன். மதுரை கேவிகேல இருந்து கேக்குதுங்க.
ஓகே அண்ணா.
Madam, கிள்ளிக்குளம் கேக்குதா மேடம்? கிள்ளிக்குளம். Hello.
அண்ணா கேக்குது கேக்குது.
Okay, madam. Thanks, madam.
லெனின்
சார் வந்துகிட்டு இருக்காங்க சார்.
ஹலோ செக். ஏன்னா மற்ற கான்ஸ்டியூவன்ட் காலேஜ்லேயும் வந்து ஜாயின் பண்ணிட்டீங்களா?
சார் குட் மார்னிங் சார். கிருஷ்ணகுமாருங்க சார், மதுரை கேவிக்கேங்க சார்.
தேங்க்யூ கிருஷ்ணகுமார். மற்ற காலேஜில் யாருக்காவது கனெக்ஷன்ஸ் வரல, அந்த மாதிரி ஏதாவது இஷ்யூ இருந்தால் மட்டும் சொல்ல சொல்லுங்கள். வேறு எங்கேயாவது இஷ்யூஸ் இல்லை ஒன்றும் பிரச்சனை இல்லை. ஏதாவது காலேஜில் வந்து ஆடியோ பிரச்சனை, வீடியோ பிரச்சனை தெரிய மாட்டேங்குது, அந்த மாதிரி ஸ்பெசிஃபிக் இஷ்யூஸ் இருந்தால் சொல்லுங்கள். அதர்வைஸ் நோ இஷ்யூஸ். வில் ஸ்டார்ட் தி கிளாஸ் பை 10:30.
சரி, இவங்க எல்லாத்தையும் இன்வைட் பண்ணியிருக்கோம் சார். பட் இவங்க மட்டும் தான் ஜாயின், இந்த 5 பேர்.
மதுரை கிளிக்குளம் திருச்சி அதுல ஜாயின் பண்ணுவாங்க. பிரபாகரன் ஜானகி சொல்றேன்.
சொல்லியா ஆர சொல்லியா மீன் சொல்லியா ரெண்டு வார்த்தை நின்றுட்டு இருக்கானே இல்லையா விஜயகுமார் எங்க இருக்கு
விஜயகுமார் புதுக்கோட்டை
விஜயகுமார் ஜாயின் பண்ணுங்க
ஆமாம் ஈச்சமட தஞ்சாவூர் இங்க எடுக்கும்போது நம்ம இங்க உட்காந்து பேசுறோம் வெள்ளிக்கிழமை ரெடி பண்ணிடுறேன் நான் உங்களுக்கு ரெடி பண்ணி உங்களுக்கு ஒரு டைம் அனுப்பிச்சுடுறேன் நீங்க கோத்ரூ பண்ணிட்டு ஏற்கனவே இருக்கிறதா இருந்தாலும் நான் அந்த கிளாஸ்ல இருந்துட்டேன்ல வளர்மைக்கும் அதை வச்சும் அப்படியே ஆரம்பிச்ச வேண்டியதான் ஏன்னா அடுத்த கிளாஸ்ல இவங்க இருப்பாங்களான்னு தெரியாது இல்லை வருவாங்கன்னு நினைக்கிறேன் கனெக்ட் பண்றதுல வந்துடுவாங்க அந்த டெக்னிக்கல் அசிஸ்டன்ட் வருவாங்க ஆரியா வந்துடுவாங்க ம் நம்ம தான் கிரியேட் பண்ணோம் பண்ணிடுவாங்க
டைமர். ஹலோ செக். ஏன்னா மதுரை யாரோ ஒருத்தர் ரெஸ்பாண்ட் பண்ணுங்க. காலர் மைக் வந்து
சார் குட் மார்னிங் சார். கிருஷ்ணகுமார் சார். செல்வம் சார்.
கிருஷ்ணகுமார் காலர் மைக் ஆடிபிளா இருக்கா
சார்?
சார் ஆடிபிள் சார்.
ஓகே
சார் லெரின் ஃப்ரம் கிளிகுளம் சார். ஆடிபிள் சார். நினைக்கிறேன். ஹலோ சார் லெரின் ஃப்ரம் கிளிகுளம் சார்.
ஆடிபிளுங்களா?
ஆடிபிள் தாங்க சார். ஆடிபிள் தாங்க சார்.
ஓகே
தேங்க்யூ சார். தேங்க்யூ.
Students, good morning.
Good morning to all. கண்ணா மற்ற கேம்பஸ்ல ஆடியோ வீடியோ எல்லாம் கேட்டா இருக்கா? Whether I am visible?
Yes sir.
எல்லா ஸ்டூடண்ட்ஸ் வந்துட்டாங்களா?
சார் கிளிகுளம் ஓகே தான்.
So we have 2 minutes more. Next class வந்து பாத்தீங்கன்னா you inform the previous teachers that at least ஒரு 5 minutes முன்னாடி அவங்கள ஸ்டூடண்ட்ஸ் அலோ பண்ண சொல்லுங்க so that they will be comfortable in the online class. So fine. So this is time. So we'll start now. So this class we are going to deal about standard soil survey, its scope, objectives. That is, we have 2 fundamentals and applied. So last class you would have seen about what is soil survey, definition of soil survey, and so on. So what is soil survey? Yes, kana neenga solunga. Just you raise your hand. What is soil survey? Very good. Please. ஏன்னா மற்றவங்களாம் வந்து keep quiet. Okay. So last class, all the students you heard about what is soil survey and some brief things about soil survey. This class, objectives, and finally application of soil survey in agriculture. So it is a broad outline of this content of this lecture. So soil survey means, so on a broader outline, it is study and mapping of soils in their natural environment. So it is not meant for any artificial environment. So what is soil, how it is being formed, and soil will be formed, it takes a lot of years. So it takes millions of years to form an inch of soil. So you are studying the soil in natural environment and you are assessing the properties and you are mapping. So how we are going about? So it is the systematic examination, description, classification, and mapping of soils. So soil survey, a single word, a syllable that indicates this whole content of the information. So you are going for examination. You are going to describe. You are going to classify. mic on ஆயிருக்கேன். மத்த கேம்பஸ் எல்லாம் மைக்கை மியூட் பண்ணிக்கங்க. So the word survey indicates a holistic picture on. So you have to systematically examine, that is either surface soil or it may be surface subsurface, and you have to analyze for all the features. Then based on the analytical parameters, you have to describe the properties of soil, and you may go for scientific classification. So throughout the world, so previously colloquially we have based on color or based on economic use, we classify the soils. So after the introduction of soil taxonomy, so we are classifying the soil on scientific manner. So throughout the globe, wherever you are going, so this cannot be changed. You can interpret the meaning and you can utilize for the potentials. And finally, you can map the data on for either a global or at country level or state level or at local level. You can map the soils and you can go for. So there are many definitions, but the Soil Science Society of America, it defines soil survey. Like the soil survey is defined as the systematic examination, description, classification, mapping of soils in an area. So this is the simplest definition defined by Soil Science Society of America. So these two lines indicate how you are scientifically approached and you are taking the data from the resources and how you are using the data for different purposes. So we have a little introduction about soil survey and its importance or its role or various whatever they mean you want. So mainly soil survey includes the assessing the properties of soil, that is characterization. And you will classify the soils based on your different properties. Then you will mark the boundary, and finally it can be for mapping. So when you are making a soil mapping, it can be utilized for variety of purposes, for crop planning, or it can be used for policy making at different levels. It can be taken for taking decisions on the different utility of the soils. And mostly the soil survey is specifically to study the morphology of soil. Just by seeing, you can easily distinguish whether it's a red soil or black soil. Among the red soil, it may be either red calcareous or red non-calcareous. If you take black soil, it may be black calcareous or it may be black non-calcareous, just based on morphology. So it may not be quantitatively correct. So it may be qualitatively fine. So for making quantitative analysis, still you have to go in deeper and you have to analyze the properties. Then based on this data, you can assess the potentials of the soil, how best this soil can be utilized. So what is the difference between soil and land? Soil and land. What is the difference between soil and land? So land encompasses all the materials within the surface of the soil, but soil is specifically meant for crop growth, right? So utility. So then based on all assessment, you can plan either at local level or at different levels like block level, taluk level, or district level, or state level, or country level. So all these being oriented towards finally a policy making. For example, you are analyzing the soil, and the soil is deficient of nitrogen. Majority of the area in this district is deficient of nitrogen. What the government will do, they will allocate more urea or more N fertilizers for particular block or particular district when the soil is highly deficient of nitrogen. And wherever the nitrogen is high, and they will restrict the movement of nitrogen fertilizer to particular district or particular state. For some state having highly P deficiency, so there they'll move majority of the P fertilizer. So like that, to make the policy decisions, all these data are necessary. Finally, when you see the numbers, our brain have the limited capacity. So beyond a capacity, you cannot assume or you cannot imagine. So to make these numbers into visual picture, so we are mapping. Okay, so all this. Why we have to go for soil survey? Why? Whether it is larger scale or at middle scale or at lower scale. Why? This picture indicates the soil is being in SAC 101. Definitely you would have studied the factors of soil formation and the soil forming processes, all these things. So all these factors and processes, it is ultimately leading to the soil formation. That means that all these factors and processes, they control the nature of the soil and its chemical properties, physical properties, all the properties, isn't it? So in one area there may be heavy downpour, heavy rainfall. In one area it may be highly drought, the moisture deficiency will be common. So the soil properties and other parameters, related parameters, are highly variable. So to assess the different properties of soil and its potentials, we are at large. For example, that first map is India map, the soils of India. So this indicates, so by number, when you say different types of soil in each district, each block, it is very difficult to count. It is very difficult to visualize. So when you see as a picture, it will be very easy. And this is for the different soils present in Tamil Nadu. And you see this picture, it is at micro level, it is at village level. So when you see this, all these pictures indicate soil is very, very heterogeneous. It's because of, due to the different kinds of factors, dominant factors may be modifying the soil property, and all the soil farming process are being governed by all these factors, right? In another slide, I explain you how all these things. So this text indicates why we have to go for soil survey. What is the need? When you are making soil survey, what you can infer? What is the quantity? What you can get from the soil survey? Right? So one is you are considering the soil as a natural three-dimensional body. So you will get the not only surface features, you will also get the subsurface features. So ultimately, what we are planning, you may be planning for either cereals, pulses, oil seeds, horticulture crops, forestry, and so on. All these crops, they require the nutrients in particular root zone. Cereals may require within surface soils, 0 to 15 centimeter, and deep rooted crops like cotton, they require up to 50 centimeter or 45 centimeter. Then tree crops, they require little more. So all the features like surface and subsurface, when you study, so it will give holistic information. And finally, based on all these things, you can also go for mapping, and you will study the individual soil properties, and all these maps, they will differ from one area to other. For example, I am mapping for Coimbatore district. I am mapping for soil properties that will not have any political boundary. So it will have only soil boundary. So you can extract limited information and very straight away to the soil properties. This is number one. And from this, you can go for scientific interpretation. And so this will give a particular information on soil. For example, soil morphology, its physical properties, chemical properties, or other soil fertility properties. So they will give very, very specific purposes, and they will give only specific information on that. So based on this, you can predict whether I have what is the existing cropping pattern, whether I want to switch over to based on potential, whether I have to modify the cropping pattern, and so on. So this is an example. So based on the potential, that is what is present here, what is needed, and how best you can modify. So all these things are being dependent on mostly from all these features. So that will be possible through soil survey. This is what you have to note. And here, when once you make a soil survey, once you assess the soil properties, once you have the basic data, then every time you need not go. When you are making a sample for resurvey, then without much additional field work, you can refine your existing work. This is number one. Then mostly the basic objectives of soil survey is almost same for all the kinds of land. So that may be saline soil, or that may be alkaline soil, or that may be problem soils in other categories. So our purpose is to explore the properties, and based on the assessment, how best that can be manipulated or how best that can be utilized. This is what. And you can also identify different constraints, that may be physical constraint or chemical constraint or biological constraint. So all these informations, they'll give the either the nature of constraint and degree of constraint. For a saline soil means whether it is at which degree of salinity is there. So that can also possible to analyze. And overall, it can increase the knowledge about the particular area or particular landscape. Then, so finally, it can be used for planning at different scale of mapping, either at a smaller scale like village level, or at larger scale at country level. So this is possible. So based on all these inputs, you can go for different resource management measures, and you can also plan for different reclamation projects and other related fields like forestry and other engineering aspects. Also, it can be planned effectively so that the present landscape can be effectively utilized. So this picture, it depicts a nutshell about what we have dealt previously. So you are already learned many things. So how you can describe the soil and its variability, number one. Number two, you are getting more information from the particular landscape or soil. Then how best this land can be improved, and you can assess. Then finally, ultimately to maintain based on all these inputs, you can maintain the soil ecosystem perfectly, so that based on all the inputs. So this is the first half indicates the what is the meaning about soil survey, how best it can be assessed, what are the utilities, and it's an intro about all these things. So now we are entering some fundamentals, basics about soil survey, how the scientific orientation behind the soil survey, right? So here, so you understand, I already just made a hint, what are the factors and processes already involved in the soil forming processes. So in previous course, you would have studied what are the different factors, just an orientation. So different factors responsible for the soil formation, and all these giving to a development of soil horizon in overall period. Then this ultimately leading to the different types of landscapes, starting from the hills to plains. Okay. So these are the different factors and the soil forming processes. So mostly the parent material, climate, topography, organism, and time. These are the 5 major factors. Based on the intensity of particular factor, the soil forming process, basic and other specific soil forming process are being happening in the different zones of soil, and finally we are getting a soil profile. And based on the assessment of the soil profile and the descriptive features, you will come to a conclusion that for which purpose the soil can be suitable. So these are the some of the just narrating what are the different factors responsible and the impact of that particular factor on soil formation. So when you have the similar climate or environment, when there are 2 parent materials, there are possibility of formation of 2 types of soil. So you may think that in a similar climate, only specific soils may be formed. No, in even a same climate or similar climate, there are possibility of different soil types. For example, if you take Lali Road to Mardamalai, you are having variety of soils. So our university is a particular location having the very specific and particular scenario where you are getting a black calcary soil like Perinagampalam series, and nearby red calcary Tulkanur series, and a colluvial soil and nearby alluvial soil. So 4 different landforms, soil types are available in a particular locality. So in a similar climate. So that indicates climate is a dominant factor, but more than that, parent material dominates. When the parent materials are different soil types are formed. So for particular type of soil, when you are making an assessment, so these are the major factors you have to be considered. And other factors like topography and parent materials, all other things, it's all leading to the formation of different kinds of soil. So it dictates one particular factor when it dominates. So it is being leading to the formation of one particular soil type. So you have to understand. So now, so history of soil survey. For example, at global level, so United States was the dominant agency in making soil survey. So I am not covering the other countries, but that too, it's a concise history of soil survey. In US, actually this is Georgia was not a part of US at that point of time. Only in later period, it is a part of a state of US. Okay. So in 1754, a Georgian royal prince, so he is Baksusti Bakrayoni. So he has much interest, and he divided based on the nature to 5 botanical agricultural zones in Georgia. So this was the, as per literature, this was the first of its kind in US. And in 1896, USDA, it approved soil survey. Then in late 90s, that is 1898 to 1899, Dakuchev, who is Dakuchev? So he was making methods and kinds how to differentiate different regions based on soil properties. Then in 1910, Zakro, he studied the soils of Georgia, and he made some assessment. And in 1952, then Sabasvi, he was the first man to classify the soils, different kinds of soil, and he published a textbook on soil stains. Then in 1966, Soil Survey, that is Survey for Resource Planning and Development Act, was passed in the US. And in 1896 to 1920, so many survey projects they have taken, and it was not only for agriculture, it is also for other fields like highways, airfields, and domestic developments were started, and different countries started their own surveys. And 1920 to 1950, the next level of survey started. So previously, it was only a conventional way, but whatever the effort made by human was possible. So in 1920 and 50s, so it is not possible to cover a larger area by human being. So the aerial survey was started. So aerial photography was introduced and it was utilized for soil survey. And 1950 to 1970, the utility of all these parameters were started using. So for land use, conservation, and other developmental activities. And in 1970 to 2000, because of the introduction of soil taxonomy, scientific classification of soils was started throughout the globe. It was started in US, but the scientific classification of soils based on soil taxonomy was introduced, and the other countries also started following. And in 2000 onwards, so this is a kind of modern era. So all the maps were only physically, it was presented in paper. Then all the countries, especially this was US, they started converting the paper into soft copies, like digitizing all the physical maps into soft copies, digital maps. Then internet access. So not only physical maps are being digitized, and it's also exported, and it was given the websites in internet. As throughout the globe, anybody wants to see different soil map of US, you can access like that. So because of the introduction of all these advanced technologies, all the countries, they wanted the information for development of or the assessment of the potentials and utility of the informations. So it has happened like a business. Then so it led to the electronic access of soil survey informations by the other agencies. For example, USDA may be making soil survey. So the other partners, they may be utilizing all these things for developmental purpose. The next level, it's very tough for making resurveys. So satellites were launched, different kinds of satellites were launched. We have Earth resource satellites. In India, we have IRS series. So all these information of from the remote sensing agencies has been sought, and this next level of advancement lead to the soil survey also can be possible by utilizing the remotely sensed data, so that at a shorter time you can cover larger area, and you can, based on ground truthing, you can confirm the properties of soil, and you can map the soil at quicker time. Then even recently, the other technologies like non-invasive field tools. So by conventional methods, you have to collect the soil sample, you have to bring to the laboratory, and you have to spend much of time, and you have to analyze, and you have to make quantitative data. But now the non-invasive tools like ground penetrating radar, electromagnetic induction, X-ray fluorescence, and other proximal sensing methods are being utilized even without collecting sample. How it is possible to record the informations. So all this, they also need the cross verification of the already we have the data. So that data can be compared, and you can take for comparison. So this is at global level, specifically in US. So in India, we have in 1846, Geological Survey was started. In 1880, Department of Agriculture was formed. And in 1889, Volker, he was the agriculture chemist. Actually, he was sent for assessing the different resources in India because of continuous famine from UK. So he started assessing different kinds of issues related to soil fertility and soil parameters, and he sent a report. And 1893, the central and provincial agriculture department started, and they also started assessing the different landscape or different suitability of for different crops. And in 1904, Z.W. Leather, he was the first imperial agriculture chemist at IRI, Pusa, Bihar. He started classifying the soil based on some scientific classification, and he started grouping the soils into alluvial, black cotton soils, red and laterite soils, just based on morphology and utility of soils. So, and 1928, Royal Commission on Agriculture, they started for assessing the different landscape for irrigation purpose, soil fertility and so on. And 1947, Stewart, he also visited and he made some initiatives at Bihar, Bengal, UP and Madras. And in 1953, United States Agency for International Development, the USAID and ICR, they combinedly they started making surveys in different parts. And in 1955, All India Soil Survey and Land Use Organizations, later it was NBSS LEP, and they started, and it was making soil survey in India. And in 1958, it was expanded, and subcenters were formed at Delhi, Nagpur, Calcutta, and Bangalore. And 75 and 76, and it was the National Bureau of Soil Survey and Land Use Planning headquarters in Nagpur was started with the sub-centers, regional centers at Bangalore, Baroda, Calcutta, Jorhat, New Delhi. So these are the initiatives by the Indian government at country level. And the All India Soil Survey and Land Use Organization was renamed into All India Soils and Land Use Survey, and some of the centers, regional centers at Delhi, Bangalore, Hyderabad, Nagpur, Calcutta. And in Tamil Nadu, in 1965, the soil survey unit was started in the Tamil Nadu government, and especially at Coimbatore, Tanjavur, Vellore, and Palayamkottai. So in different periods with the Tamil Nadu government, they started. And this slide indicates the systematic study of the soils and soil survey information of Tamil Nadu. And in 1912, the soil fertility status was assessed in Kaveri Delta zone, and 1934 to 36, the different irrigation projects were initiated, and for that purpose, soil survey was conducted in Lower Bhavani, Toludur, Kaveri, and Mettur. And 1965 to 86, specific soil mapping project was started in different taluks of Tamil Nadu, and 80 to 84, the coastal soils and their properties were surveyed and it was mapped. And 1994 to 97, and the different organizations like NBS LEP Bangalore, they combined and they made survey in the holistic country with the help of other universities and so on. So this is a background or history about at global level, at country level, and at Tamil Nadu level. And when you have a soil survey, what are the linkages? What are the things to be done? So first you have to go for field work. So necessarily you have to conventional survey. We have to enter the field. You have to assess the morphology. You have to assess the natural vegetation, and you have to consider all the parameters. So it involves field work, and we collect the soil samples. Either it may be of surface sample or soil profile sample, and you bring the soil sample to the laboratory and you analyze the properties concerned for either based on necessity, either for development of cropland or for scientific classification. So based on necessity, you will assess the soil properties and you will correlate the soil property with the demand. So we have supply and demand. So what is the purpose of the data for utilize? So you can correlate, and you can also map the data, and you can produce soil fertility maps, constraint maps, and so on. And you can also transfer this technology from lab to land. For example, we have KBKs. So all this information can be transferred to KBKs. For example, if you have saline soil or alkali soil, or you have physical constraints or chemical constraints, for all these informations can be transferred to the KBKs and other stations for the development of the farmers. So based on this, in nutshell, and the importance of soil, why we have all these things. So this involves some importance about the soil survey. So first hand, it gives the information on soil resources. So when you want to make inventory on soil, all these different properties of soil is being governed. So all this reflects on the soil resource inventory, and it gives the spatial distribution of all these properties, like starting from the physical property, physicochemical property, and fertility properties. All these spatial distribution can be possible, and you can assess. So when you have all these information, the soil use for the right purpose can be possible. And when you use the soil for improper purpose, naturally it will lead to soil degradation. That also you can be easily assessed. And finally, it can be used for regional planning, and you can harvest the potential of soils, and you can make the different conservation practices, and you can make policies at different levels, like a state or country level or local level, and it will be highly useful for variety of developmental projects, like including watershed development program at different panchayat or farm level or at different state levels. And when you see the scope, for example, a farmer without going for without soil survey or without any basic idea, when he going for cultivation, for example, the crop, it normally chooses a soil pH of 6 to 7.5, and it needs very well drained soil. But when you grow the crop which is require more clay content, then you cannot harvest good crop. So you have to see what the crop requires and what the soil you have. So you have to grow the right crop in right soil. So for when you have heterogeneous soil type, like the soil may contain, black soil may contain monomalent type of clay which is having high water holding capacity. So you cannot grow tuber crops in black soil. And you have red and laterite soils, where these soils have kyanite type of clay mineral. This is highly porous. They have less Cs, like 15 centimole proton per kg. So these soils are highly suitable for tuber crops. So when you are changing the crop, then you are not harvesting the right purpose. So you can plan accordingly what are the resources you have. Then similarly, some of the crops, they require specific crops. For example, some crops will not come in some of the soils. When you have the soil with conical nodules, some of these crops, sensitive crops like citrus, it may not come. So you have to change the cropping pattern. Then when you have, as a civil engineer, in first class you would have studied as a civil engineer how he assumes soil. So when you have the subsurface gypsum, so you cannot go for construction. And also when you have shrinks clay types like monumental, then all the pipelines can be broken or it's not possible. So when you have holistic soil survey, not only for agriculture, it is also possible for other field of soils in like engineering and other similar allied plants. So based on this, you have two main objectives of soil survey. One is to describe and classify the soils, giving uniform system of classification with uniform nomenclature in order to correlate the soils of different area. So but just based on qualitative data, when you are classifying soil, you cannot compare from region to region. From Karnataka, you can compare with Tamil Nadu. From here to you cannot compare with Uttar Pradesh. So when you classify the soil based on scientific nomenclature, it can be easily compared, easily understood, and easily planned. Then to show the distribution of different soils in field, that is in soil mapping, is possible. So these are main two objectives of soil survey. So these objectives are mostly in two categories. One is fundamental and applied. What related to fundamental? So here the fundamental objective is to assess the properties of soil, its genesis, classification for sustainable development. So fundamental, for example, why we are need of fundamental soil survey? So we are having scientific nomenclature for soil. For example, if it is alpisol, what is alpisol? What is alpisol? So definitely previously you would have studied different soil orders. So order, yes. So alpisol is a red or laterite soil, is it not? So scientific classification starting from order suborder, grade group, subgroups up to series level. So order will have some specific property based on different soil forming processes, isn't that? So when you scientifically classify anywhere in the country, anywhere in the globe, it can be systematically assessed and systematically you can plan. And these other similar classification also possible where land capability classification, land suitable, all is possible based on the soil genesis and soil properties. So applied soil survey, next objective is applied soil survey. In applied soil survey we have for which purpose we are utilizing this data for productive purpose like agriculture, forestry, engineering, urban development, or the knowledge can be transferred by different other agents like KVKs and so on. So transferring of technology, and these informations can be provided for developing optimum land use, and you can also go for delineating degraded lands, and in other features, other agriculture features like delineating pest infection, disease mapping, and so on. Then based on all these assumptions, so soil survey is an integral part of agriculture research and other programs. And how you can apply these all the soil survey informations in practically. So these are the in nutshell about the developing land classification, correlating soil properties of different regions with the region to region, and planning agriculture research and extending the result to other categories. And you can also provide the information for developing optimal land use, and you can determine the potential of the particular landscape, and you can make the adaptability of individual crops and soil management, and the prompt application of new discoveries in soil and crop management. And you can also easily identify the nutrient deficient soil and map it, and you can describe the problem soils, you can transfer technology, you can plan for other similar areas of development methods. So these are the advancements in soil survey. So previously there were conventional soil survey and then aerial survey and remote sensing. So these are the starting from conventional to the present day agriculture. And next, how the future survey and technology is possible. So here unmanned aerial vehicles, for example, we have drone. This year we have, from just 2 to 3 years before, the other countries have unmanned vehicles. Now in India, drones are possible. So you can use unmanned vehicles for soil survey. Then mobile 3D mapping. So all the maps are only 2-dimensional, in the X and Y axis, is it not? And now what the next coming years, what the scientists are going to, they are going for 3D mapping. So Z axis also possible. So you can visualize the soil in 3 dimensions. Then laser scanning, LIDAR, light detection and ranging. The laser beams are being passed and you are getting many information, particularly for pest and disease. The behavior of insects are possible based on the laser beams passed by the LIDARs. And also new disciplines like geomatics. So in civil engineering, geomatics, a new subject has been launched recently. This is gaining a momentum. So what is geomatics? So it is a discipline of gathering, storing, processing, delivering spatial reference information. So this geomatics involves the study of the field surveying, mapping, remote sensing, photogrammetry, hydrography, GPS and GS. So this is the next level of soil survey in due course. So you have variety of features and soil survey has greater potential in due course. And these pictures will show how the soils can be effectively classified, assessed. Just it's a picture showing the land capability class. So there are 8 classes. The first 4 classes will be suitable for agriculture, and the last 4 will not be suitable for agriculture, and it will be suitable for forestry and other purpose. So just for assessment. And you take the first picture that shows the different constraints of soil in Tamil Nadu. And next picture shows the the sulfur content of the soil and its mapping in particular area. And this even in a local area, small field, the heterogeneous property of soil is being noted. So this shows that soil is heterogeneous. When mapping is done, you can use the soil in the advancement of science. And next picture shows how best the new technologies can be adopted and how the new survey can be improved, and you can forecast the development of science in future. When you have all the information in your hand, now the era is precision farming, isn't it? So when you have the georeference maps, so all these maps can be possible, and you can apply the fertilizers, and you can apply all the scientific interventions based on precision farming. All these will be highly useful for making your sustained development through precision agriculture. So for that, you need, or you should have the intervention of the advanced technologies where we have the georeference maps and so on. So when you have all these things, all the quantitative and quality data of soil survey, it is possible to recheck, and you can utilize all the data for sustained development of soil and crop planning at various levels of policy making. So if you have any doubt, you can ask. Other campus? If you have any doubt, you can ask. You can unmute your mic. And the different types of soil survey and other topics will be covered. யாருக்குமே டவுட் இல்லையா? அம்மா கிளாஸ்ல don't have doubt? மதுரை, கிள்ளிக்குளம், எல்லாருமே இருக்கிறாங்களா?
சார் மதுரை சார்.
எஸ்.
நோ டவுட்.
யாருக்குமே டவுட் இல்லையா? Okay, fine. So can we close the lecture? கிள்ளிக்குளம், திருச்சி, ஈச்சங்கோட்டை, குடுமியான்மலை. So I have uploaded the theory notes and also PowerPoint in the Microsoft Teams. So other colleagues, you can download and you can also give it for the students. And subsequent classes we have to have, and all the teachers are requested to upload your notes and PowerPoint on Friday in the Microsoft Teams, so that the students can download and they can read. And you have to invite all the deans and the heads of the department for joining. If they are intended to join, they can join. So can we close here? Krishna Kumar.
Thank you.
Okay, thank you all. We'll see you in next lectures.